A rocket is fired upward from some initial distance above the ground. Its height in feet h above the ground as seconds after it is fired is given by the formula h is equal to negative 16s squared plus 128s plus 768. Find its maximum height when the rocket reaches its maximum height and when it reaches the ground. Let's use our calculator to explore a little bit. Now, on your calculator, the dependent variable is not h, the dependent variable is y, so you want to use y rather than h. Also, the independent variable on your calculator is not s, it's x, so you want to enter y is equal to negative 16 times x squared plus 128 times x plus 768. So on your calculator, first of all, go to y equals to enter the equation. Type in minus 16x squared plus 128x plus 768. Make sure when you enter the minus for minus 16x squared that you're using the negation key next to the decimal point and not the subtraction symbol above the addition symbol. Alright, well, once you've entered the equation into the calculator, you're ready to set up a table. So you're going to go to second window, which is table set, second window. For a table start, enter 0 for 0 seconds. That will help us to determine the initial height of the rocket. Set the table increment at 1 so that we can explore what happens 1 second at a time. What we expect is that the rocket will go up and then eventually come back down. Make sure you leave the independent and the dependent variable on auto. Once your table is set up, go to table, which is second graph. Use your down arrow key to scroll through the table and observe what's happening to the height of the rocket. Notice that initially the rocket starts out at a height of 768 feet. Then the rocket goes upward. After 1 second, it's at 880 feet. After 2 seconds, 960 feet. After 3 seconds, 1008 feet. After 4 seconds, 1024 feet. After 5 seconds, it started on its way back down. It's down to 1008 feet again. So when we're trying to determine what is the maximum height of the rocket, it would appear that the maximum height is 1024 feet and that the rocket reaches that height after 4 seconds. In order to determine when the rocket reaches the ground, we need to continue scrolling through the table until we observe that the height of the rocket is 0. So continue scrolling through the table until you locate the point at which the y value is equal to 0. And notice that when we reach time is equal to 12 seconds, the height of the rocket is 0. So after it is fired, the rocket reaches the ground after 12 seconds. So we're able to answer the questions using the table of values, but to reinforce this idea, let's also produce a graph. In order to sketch a graph, we need to have a good viewing window. So first of all, go to Window. When you get to Window, enter 0 for x minimum, because that corresponds with time equals 0. Enter 12 for x maximum because that corresponds with the value of time when the rocket hits the ground, and an x scale of 1 would be appropriate. Now for our y values, we can use zoom fit so that the calculator will go through and determine the best fit viewing window for the time from 0 to 12. So go to zoom and then scroll through the zoom menu until you find zoom fit. A zoom fit is right after 9. Okay, and what we can see is that the rocket goes up and then it comes back down and reaches the ground after 12 seconds. If we want to determine the maximum height using the calculator, we can use calculate maximum. So you want to go to second trace, that brings up the calc menu. Notice that the fourth option is maximum. We want to determine what is the maximum height of the rocket. So select number 4 and then follow the prompts. First of all, it asks for a left bound. So you're going to use the left arrow key to move to the left of the maximum point and then press enter. Next, it'll ask you for a right bound. So you use the right arrow key to scroll to the right of the maximum point and then press enter. And then finally, you'll use the left endpoint to move right to the highest point, press enter, and the calculator will evaluate the maximum value of the function. So again, use the left arrow key to move to the left of the highest point, press enter, then use the right arrow key to move to the right of the highest point, press enter, and then for the guess, move right to the highest point, press enter, and when the calculator says maximum at the bottom, it gives you the coordinates of the highest point, which is called the vertex. In this case, the x coordinate is 4, the y coordinate is 1024. So the maximum height of the rocket is 1024 feet. It takes 4 seconds for the rocket to reach its maximum height, and then after it is fired, the rocket reaches the ground after 12 seconds. So what is the maximum height? We determined that it was 1024 feet. This occurred after 4 seconds. And after it is fired, the rocket reaches the ground at s is equal to 12 seconds. Now, in order to determine these values by hand, we would follow this procedure. Part 2 would be the easiest place to start. How long does it take for the rocket to reach its maximum height? Well, the rocket reaches its maximum height when at the vertex of the parabola. In order to find the vertex of the parabola, we use the formula minus b divided by 2a. b is the coefficient of s. So the coefficient of s is 128. We put minus 128 divided by 2 times the a value. A is the coefficient of s squared, which is negative 16. When we evaluate this, we get negative 128 divided by negative 32, which is 4. So how long does it take for the rocket to reach its maximum height? 4 seconds. For part 1, what is the maximum height? Well, in order to determine the maximum height, we need to substitute 4 into the in for s in the equation. So we'll find h when s is equal to 4. So h is equal to negative 16 times the square of 4 plus 128 multiplied by 4 plus 768. So use a calculator to evaluate. Negative 16 times the square of 4 plus 128 multiplied by 4 plus 768. And that comes out to 1024, which matches what we got before. So what is the maximum height? 1024 feet. In part 3, we want to determine how long it takes for the rocket to reach the ground. Well, the rocket reaches the ground when the height is equal to 0. So we want to find S when h is equal to 0. So we substitute 0 for h and we get 0 is equal to negative 16s squared plus 128s plus 768. Well, this is a quadratic equation. We have 0 on one side, so we can factor the right hand side. Negative 16 is a factor of all three terms. So let's factor out negative 16. That leaves us with s squared. 128 divided by negative 16 is equal to negative 8. So we get minus 8s. And 768 divided by negative 16 is negative 48. So now we need to factor the trinomial factor. We know that s times s is equal to s squared. And then we need to think of two factors of negative 48 that add up to negative 8. Well, negative 12 and positive 4 multiply to negative 48 and add up to negative 8. So this is the factorization. And then in order for a product to be 0, one of the factors must be 0. Negative 16 does not equal 0. So that means that either s minus 12 is equal to 0 or s plus 4 is equal to 0. And then we solve each of these. S is equal to 12 or s is equal to negative 4. Well, negative 4 doesn't make sense in the context of this problem because that's before the rocket was fired. The solution is s is equal to 12. So after it is fired, the rocket reaches the ground at s is equal to 12 seconds.